Hey everyone, and welcome. Today, we're going to get into something absolutely essential for any C programmer: how you handle complex data and, more importantly, how you make it stick around. We're talking about going from a jumble of variables to a real application that actually remembers stuff. All right, let's get right into it.
So let's kick things off with a pretty basic question. Just think about any app you use, a game, your contacts list, whatever. How does it keep track of information that belongs together? How does it know that your name, your ID, and your score are all about one person? You? Well, you could try to manage it the messy way, like you see over on the left, just a bunch of separate variables floating around. I mean, it kind of works, but it's clunky, it's a headache to manage. But then look at the right. One single tidy unit that holds everything. Now that is the kind of clean, organized code we're aiming for. And to get that clean approach, we need our first major tool. And this is where C structures come into play. The best way to think about them is as a custom-made blueprint for your data. So what is a struct, really? Well, the official definition calls it a user-defined data type. All that means is that you, the programmer, get to invent your own data type. You can bundle together a string of text, a whole number, and a decimal number, and package them all into one new thing. And here's a really great way to picture this. Just think of a student's ID card, right? It's got a name, an ID number, maybe a photo, all totally different kinds of information. But they're all on that one card because they all describe one single student. A struct is just like that card. And here's what that blueprint looks like in actual C code. We're literally defining a new thing called struct student. And inside those curly braces, we're just listing the ingredients. We're telling the computer, hey, any student I make from now on is going to have a spot for a name, a roll number, and their marks. Notice it doesn't hold any data yet, it's just the template. Okay, so this is great. Our data is all neatly organized in the computer's memory using our new blueprint. But we've just run into our next big problem. What happens when you close the program? Everything that was in memory, poof, it's gone, finished. So how in the world do we make our data last? And that question leads us directly to the second piece of our puzzle: handling files. This is how we take that perfectly structured data and save it somewhere permanent, somewhere it can live even after our program is done running. Let's go back to our analogy. If the struct is the student ID card, then you can think of a file as the storage box or maybe the filing cabinet where you keep all those ID cards. The program can end, you can turn off the computer, but that box is still there, and all the cards are safe inside. Now, working with files in C follows this really simple, logical three-step dance. First, you have to open the storage box. Second, you do your thing. You either put something in or take something out. And third, and this is super important, you always close the box when you're finished. Open, act, close. That's the rhythm. And of course, C gives us a specific tool for each of those steps. To open the box, you'll use fopen. To write data to the file, think print to file. That's fprintf. To get data back out of the file, you scan from file with fscanf. And when it's all said and done, you clean up with fclose. These four are your workhorses for basic file stuff. Okay, enough theory. This is where it gets really fun. We have our data blueprint, the struct, and we have our storage box, the file. Now it's time to put them together and actually build something useful, a simple little student record manager. So what's this little app going to do? It's pretty straightforward. We'll be able to add the details for a new student, we'll save that record permanently to a file, and then, this is the magic part, we can run the program again later to pull up and display every single record we've ever saved. So here's the flow. Step 1. Our program asks the user for the student's name, their roll number, and their marks. It takes those 3 pieces of info and neatly packs them into our student struct variable, which is sitting in memory. Next up, we open our storage box, which is just a text file. Then we use a function like fprintf to basically copy the information from our organized struct and write it right into that file. Just like that, our ID card is now officially in the filing cabinet. And finally, we complete the circle. We can open that same file again later, use fscanf to read the data back out, and use it to fill up a brand new student struct in memory. And from there, we can display it on the screen. The data didn't just disappear, it persisted. So let's zoom out for a second. What does all this really mean? Well, this combination, Using structures to organize your data and files to save it isn't just some academic exercise. It's the fundamental building block for almost any application that needs to remember anything at all. And that right there is the big takeaway. Once you master these two concepts, you've really leveled up. You've gone from writing programs that just do a calculation and immediately forget to creating C applications that can actually store, manage, and retrieve meaningful information over time. It's a total game changer. So I'm going to leave you with this final thought. Now that you know how to create these data blueprints and give your programs a permanent memory, what are you going to build? A simple contact list, an inventory manager for a hobby, a personal journal? The door is wide open now. So what problem are you going to solve first?